Once again, I'm Seth Grimes. I am the founder of the New York Natural Language Processing Meetup, and I took over last year running the Washington, DC, that is, Natural Language Processing Meetup. This is the third program that we have moved online rather than holding them in person, of course. And I'm thrilled that we have as co-sponsors of today's meetup Ann Arbor, Detroit NLPers, the Hungarian Natural Language Processing Meetup, and London Text Analytics. It's great to have the support, and we've timed this program, and we will time subsequent programs to make them accessible to people in the US Pacific time zone, US Eastern, as well as in the UK and in Central European time. So thanks to you all for joining us today, whichever meetup that you came from. We're going to have two speakers today. They are Lucy Lu Wang and Kyle Lowe from Alan AI, who are going to talk about the COVID Open Research Dataset, CORD-19. And then we've added a second speaker just toward the end of last week, Róbert Péter, who is representing, who is from the University of Szeged in Hungary, who is going to be talking about a particular text mining tool that uses CORD-19. First, I'm going to inflict on you a short advertisement, actually two of them, that I think will be of interest to Meetup members. First of all, if you are looking for as-a-service text analysis, as-a-service natural language processing, that is, my friend Dr. Robert Dale has put together a guidebook, a consumer guide for text analytics APIs. This could be of interest to data scientists and to software developers who are building applications using NLP functions. And then secondly, I also organize conferences. I have one coming up a week from tomorrow. It is the Emotion AI conference. It covers technologies that apply natural language processing, voice tech, facial coding, neuroscience methods to understand emotion in text and speech for conversational AI for various purposes. It is a technology conference, and it is taking place online from 9 a.m. to 5 p.m. in the US Eastern time zone. So I hope you can join us. The address to go to is emotionai20.com. It is a commercial conference, and I'm offering Meetup members, anyone who's attending, and feel free to share it, a 20% discount via the Meetup discount code. So please check out the conference. We have some great speakers. They include Professor Bing Liu from the University of Illinois, Chicago, who's a pioneer in sentiment and emotion analytics, as well as a whole spectrum of other really interesting speakers. Okay, enough of all that. I'm going to stop my share, and I'm going to allow our speakers, who are Lucy Lu Wang and Kyle Lowe from Alan AI, to take over. And I turn the podium over to you. Lucy?
Thank you, Seth. Let me just bear with me a moment as I switch over. Can everyone see my screen?
Very good, Lucy.
Great, thank you. Thanks, Seth. Thanks so much for inviting Kyle and I to come and speak on for this meetup. So as you mentioned today, we will be discussing the CORD-19 dataset, or that's the COVID-19 Open Research Dataset. And my name's Lucy Lu Wang, and with my co-presenter Kyle Lowe, we will be discussing how this dataset was created, as well as some of the downstream research products that have come out of this dataset. Both of us, Kyle and I, are research scientists from the Allen Institute for AI, otherwise known as AI2. And AI2 is a nonprofit research institute based in Seattle that was founded by the late Paul Allen. For some context, both Kyle and I work on a project called Semantic Scholar, located at AI2. So Semantic Scholar is a literature search engine that was created about 5 years ago. And since then, Semantic Scholar has indexed over 40 million full-text articles and up to 200 million papers across various scientific disciplines. And the idea for this tool is to create a place where we can kind of test these various AI-powered tools for discovering, reading, and understanding the scientific literature. So the team releases a lot of open source things like language models trained on scientific text, paper recommendation engines, systems for augmented reading, entity extraction, and so on. And these resources are available on the Semantic Scholar page. So as context, we're a group that works primarily on scientific NLP. And what we mean by that is applying natural language processing methods to the scientific literature. And CORD-19, this data set of COVID-19 related research, kind of falls right under that umbrella. So as mentioned here, this is a data set of machine readable research papers on the subject of COVID-19 and related coronaviruses. And the data set was released first on March 16th, 2020, which is a little bit more than a month ago now. And it's received a lot of interest. We've had, more than 1.5 million viewers of the data set, and the data set has been downloaded more than 75,000 times since its release, probably a little bit more than that now even. When we were first tasked with releasing the data set, we had kind of very little time to turn it over. The first iteration of the data set was released maybe 3 days after we got the message from the White House Office of Science and Technology Policy that we were going to try to release a data set like this to kind of spur text mining on the COVID-19 research. And since then, the data set has also been updated very regularly to include kind of the latest research. So the goals of CORD-19 are to be kind of like a reasonably comprehensive data set of the scientific papers on this subject. The data set has to stay up to date with the latest research. It has to include clean metadata for accessing the papers within the data set, as well as clear provenance for where those papers come from and where people can go to retrieve those papers. And lastly, and probably most importantly, the data set format has to enable people to perform text mining and information retrieval on the full text of these included documents. And here I've borrowed a figure from COVID-19 Primer to just show the scale of new research being published on COVID-19. So as you can see, since the kind of beginning of the year or around mid-January, the number of new papers being published about COVID-19 has increased pretty dramatically. We're up to almost 7,000 new publications now. And most importantly, the rate of these publications is increasing. So there's there's hundreds of papers being published every day now. So CORD-19 includes all of these new papers on COVID-19, as well as historical papers, as I mentioned. So as of April 24th, 2020, which was the latest release of CORD-19, the data set included approximately 57,000 papers and preprints, of which around 46,000 come with full text. So if you look a little bit more deeply into the data set, the vast majority of the papers represent studies conducted in biology, medicine, or chemistry. But if you look a little bit deeper at the subfields being represented, unsurprisingly, many of the papers come from field of virology, followed by immunology, molecular biology, and so on. And to understand kind of the temporal distribution of these papers, I'm just showing here the publication times of the papers in CORD-19. So as you can see, we've known about coronaviruses for quite some time, but interest really, at least research interest has really increased following the SARS and MERS epidemics of 2002 and 2012. and also the most recent COVID-19 epidemic, which resulted in kind of a very large spike in research output. And there's, I think there's value in including these historic research publications. It's important to know how COVID-19 differs from previous coronaviruses like SARS and MERS. There are things that we learned about SARS and MERS that perhaps transfer well to COVID-19, and other things we've learned that probably don't. And some of these learnings could potentially affect our containment strategies around COVID-19. And here's how CORD-19 is constructed. So we combine articles from numerous sources. Our primary sources are the World Health Organization, which maintains a manually curated list of COVID-19 publications that's updated regularly. PubMed Central at the National Library of Medicine, which is a kind of open access repository of biomedical literature. And through the COVID-19 initiative there, PubMed Central has been working with a lot of publishers to make their historical and current COVID-19 articles available under open access licenses. And we also work with preprint servers like bioRxiv and medRxiv, which are two of the largest preprint servers in biology and medicine, respectively. And in addition to these sources, we also at Semantic Scholar kind of leverage our relationships with various publishers to try to provide additional full text for the corpus. So from each of these sources, we actually obtain metadata for the papers that are relevant to COVID-19, as well as like a number of files corresponding to the paper metadata, things like PDFs or in some cases XMLs. And for CORD-19, we take the metadata and files and we produce both a harmonized metadata output as well as parses for the documents associated with these papers into a structured JSON output format. So we take the PDFs, we extract the full text, and release that as well. So what does this look like? The metadata file has one entry corresponding to each paper object. Each paper object receives its own unique identifier, which is in that first column, and is also associated with common paper metadata attributes such as title, authors, publication date, etc. And each document that has corresponding full text also has something like a PDF ID, which links it to the PDF document from which the body text is extracted. And the body text we extract into this structured JSON format that preserves a lot of the key parts of the article. We preserve things like paragraph breaks, section headers, as well as inline citation spans and mentions of figures and tables. You can see a little example snippet of that on the right there. And the reason we release structured JSON is because having a single kind of structured output for or structured representation for these papers allows us to share and reuse annotations made on top of this text. So an example here is in this span of text, certain medical entities like hypertension or ARDS, which is acute respiratory distress syndrome, can be recognized and linked to the corresponding terms in various terminologies like MESH, medical subject headings, or ICD-10, which is a clinical terminology. And we also have these citing spans, which we can then link to other papers in the corpus or out in kind of the overall scientific corpus which is referenced by this particular paper. So then, given these structured full text representations and the metadata in CORD-19, we're hoping to encourage and enable this kind of work where, given kind of a medically relevant query, such as, does hypertension increase the risks associated with COVID-19? We can build systems that retrieve the relevant articles out of CORD-19 and then are able to extract the supporting evidence or the snippets of text that provide supporting evidence for an answer to the query. And of course, it's important for us to have full text representation because in many cases, although things like title and abstract are really easily accessible for some of these papers, the answers to these questions are not located in the abstracts. They are often found either in the full text of these documents or sometimes in the tables or figures that are also a part of these documents. So that's kind of like a summary of where the CORD-19 dataset is right now. So these are the features that we sought to incorporate when we designed the dataset. So in order to be comprehensive, we're incorporating papers and preprints from multiple different sources. To remain up to date, we have a kind of regularly scheduled update cycle. We provide harmonized and deduplicated metadata and also provide the sources and licenses associated with each of the papers included in CORD-19. And lastly, the structured JSON representation of full text allows people to perform text mining and also to share and reuse annotations. There are, of course, a number of challenges that in scientific NLP that very much affect the use of CORD-19. And here I'm just summarizing a few of these challenges. First of all, PDF is not a very suitable format for text mining. PDF is designed for viewing a document, and in order to extract full text and content out of PDF, kind of a lot has to be done, and the results are not necessarily very deterministic. Some articles come in other more structured formats like XML, and in those cases, we also provide an XML parse for that data. Another challenge is that only a limited number of papers are open access. So in cases where a paper might be very relevant to COVID-19 but doesn't talk about COVID-19 or coronaviruses directly, those papers are not included in the CORD-19 dataset, but could provide useful answers for the public. And the last challenge is that, of course, the metadata that we receive from various archives and publishers is they're not standardized in the same way, which makes harmonization difficult. And many of these archives also duplicate each other's materials. So cleaning and harmonization is a big effort. So looking ahead for the data set, we are moving towards faster updates, trying to switch from a weekly cadence to a daily cadence. This is, of course, more and more necessary as the number of papers being published every day increases dramatically. And we're also trying to make content improvements. So we'll be adding new features like citation resolution and table parses, which is one of the most requested features. And we're also hoping to add more articles and content from different sources. A lot of publishers have very generously made their COVID-19 papers open access, which is why we've been able to create the CORD-19 dataset in the first place. However, the papers in CORD-19 cover only a small portion of the overall literature graph relevant to the coronavirus epidemic. So for example, a lot of the papers cited by papers in CORD-19 are not in the corpus. So we believe that the users of the data set could really benefit from the inclusion of additional content. So we're hoping to work with publishers to make more of their content open access for text mining on COVID-19. And now I'm going to take a brief pause to turn it over to my co-presenter Kyle, who will discuss some of the ways the data set is being used by the community. And I'll maybe also take this opportunity to look through the Q&A. I think there's been a couple of chats.
In the chat.
Yeah, sorry, I was unable to keep track of the chat while.
You have 2 in the Q&A and 3 in the chat. You can answer them now or defer them.
Go ahead. Go ahead, Lucy, while I mess with this.
Yeah, go for it. Yes, so from Eleanor, where their sources coming from, hopefully I was able to answer your question, but primarily the WHO COVID list, PubMed Central, bioRxiv, medRxiv, as well as some of our publishers, some of the publishers who work directly with Semantic Scholar. Yes, so the Microsoft Academic Field of Study labels are not currently available for the papers in the data set. Actually, that's not true. We released a supplementary file on the CORD-19 landing page with the Microsoft Academic, the MAG identifiers for all the papers. So although the field of study labels aren't available for each of the papers, you can use the MAG identifiers in that supplementary file to query for the field of study labels, I believe. Yes, so something I maybe didn't mention, this is from Khalees Wang, I think, about the peer-reviewed, like how many of these articles are peer-reviewed. So anything that's, I'm gonna make a general statement that is potentially not completely true given the current situation, and things are kind of in flux and changing. So anything that's in bioRxiv or medRxiv, the preprint servers, those are not peer-reviewed. They are preprints. For anything being archived by PubMed Central, I do believe those works have gone to peer review in some sense. But the corpus, the data set, does include papers that are both peer-reviewed and non-peer reviewed. Yes, and then removing duplicates is a big challenging question. We have leveraged a combination of kind of unique identifiers and paper metadata to try to remove duplicates. We've really chosen a very conservative approach for removing duplicates because we would rather include maybe 2 variants of a paper that are similar but somewhat different, rather than kind of removing something that we consider to be a duplicate but actually included important information. So we definitely removed anything where the papers are obviously duplicates. They share different identifiers, have the same title, etc. But it's this is very much an open question. Maybe Kyle, you can go ahead, and we will take some more questions after Kyle talks about.
Oh, I mean, yeah, sure.
Yeah.
Okay. I mean, there are a lot of questions. Wow. Okay. You can see the screen.
Yeah. Yeah.
Right.
I will probably also address these questions as you speak.
Sounds good. Okay. So thanks, Lucy. In the months since the release of CORD-19, we've been in contact with quite a few research groups who are building applications aiming to help medical experts find answers to COVID-19 related questions from the literature. And while we're aware that some work has been done to train, say, like COVID-19 specific modeling resources or construct COVID-19 specific knowledge graphs, the vast majority of systems have focused on retrieving relevant articles or extracting relevant information from those articles. There are a lot of different search engines out there that try to provide this service. We've tried keeping track of them on our public forum. There's a screenshot provided, but I'm sure there's like way more out there that we don't know about. And to get a sense of the diversity of the approaches that people are using, I'll go through a few examples to illustrate how different groups have been focusing on different user experiences or different underlying machine learning technologies. Most tools are fairly lightweight in terms of their interfaces, with minimal search, like a search bar, nothing else. And they place a lot more emphasis on improving the underlying ranking models. So for example, this is a screenshot from a system from the University of Waterloo and NYU, which demonstrates the use of T5 as a re-ranker on top of an initial BM25 retrieval step. Other systems, like this one from Microsoft Azure, use simple default rankers, BM25 implemented Lucene, and instead focus on entity extraction. So what they do is they surface these entities as facets that users can then use as filters. And of course, there are some systems like this work from Korean University, which approach the problem as question answering, where instead of retrieving whole papers that may be relevant to a query, they retrieve text snippets that answer the question directly. Ultimately, the common goal of these systems is to help medical experts find answers to their questions from the literature. But as we saw, there are so many systems out there. It's currently difficult to know which ones are actually helpful for medical experts, that is, which ones are actually retrieving the right papers or answering questions correctly. Furthermore, as developers of these systems, we need to know which text finding methods, techniques, or approaches are actually worth adopting or investing more time into. This is where it's important to keep medical experts in the loop when developing these systems so that they can provide continuous feedback, which helps developers improve on the design of these tools and also refine the accuracy and relevance of the underlying machine predictions. While we're on this topic, I'd like to talk a little bit about shared tasks and competitions and their role in bridging the gap between medical experts and system developers. In short, in organizing these large-scale competitions, we can pool valuable time and effort of medical experts to simultaneously and efficiently evaluate many different systems on a level playing field. I'll discuss two notable tasks centered around CORD-19. First is the ongoing CORD-19 Research Challenge on Kaggle, which is an online competition focused a bit more on information extraction. Then I'll discuss a recently launched shared task focused on information retrieval, which will be part of the TREC 2020 conference. So the CORD-19 Research Challenge on Kaggle launched in coordination with our initial CORD-19 release about a month ago. It prompts dozens of key scientific questions about the current pandemic, such as what are the primary risk factors for COVID-19? Participants extract answers to these questions from the literature using various text mining techniques and submit them for assessment by medical experts. These submissions are then judged not just on their accuracy and usefulness, but also on other factors, such as how understandable they are. And while this makes the evaluation more open-ended, it does mean submissions that involve some additional form of synthesis or summarization over the extracted findings are rewarded for their efforts. The initial round of submissions finished recently with over 500 participating teams, I think 550 even, making it one of the most popular challenges in Kaggle history. Of course, with a large number of participants, this manual evaluation process is very time-consuming and extremely difficult to scale up, especially as more papers get added to the corpus and we want to consider adding questions to the existing list. The Kaggle Challenge has also been a great catalyst for forming spin-off projects. We wanted to highlight one such effort that's especially exciting because it demonstrates one way medical and text mining experts can collaborate closely together. This is a project which aims to create semi-automated living literature reviews. It still involves extraction of findings from papers to answer the Kaggle set of questions, and extractions are still assessed by medical experts. So nothing's changed there. But the interesting bit is that the medical experts use the collected extractions to define schemas for tables that summarize all the findings from the literature in an easy to read format. See the example on the slide. These schemas then further inform what additional information needs to be extracted for a complete answer, which helps focus text finding efforts. This project is still ongoing, and we're really looking forward to seeing what comes out of this one. Next I'll talk about the Trek COVID share task, which launched recently. It's an ad hoc retrieval task, and it's another competition separate from the Kaggle one. We are co-organizing this one with collaborators at NIST, OHSU, UT Health, and the National Library of Medicine. This task is pretty familiar. That is, given a set of COVID-19 topics, such as about testing or treatments or virus origin, participants build systems that can retrieve relevant papers from CORD-19 and order them from most to least relevant with respect to that topic. These rankings are then compared to gold rankings provided by medical experts. What's actually especially interesting about this task is that it tests participants' abilities to quickly bootstrap retrieval systems that are useful in a real-world setting where information need is very urgent. This means that participants need to handle a corpus that is constantly changing over time. They also need to handle addition of new topics, which are curated from real information-seeking queries issued on Medline. What this means is that the systems need to handle real-world messiness in these queries, such as whether a query about coronavirus is actually asking about specifically COVID-19, or if historical coronavirus research is also relevant to that query. We just finished round 1 last week with over 50 team submissions, despite the submission period only being open for about a week, which is quite incredible. We've begun to analyze the results already and already have some learnings. One interesting thing we found, for example, is the importance of including full text to boost search relevance. But this comes from indexing individual paragraphs in the full text as opposed to indexing the entire articles as one unit, which can actually harm relevance. So that's sort of an interesting initial finding so far. Round two is set to begin May 4th, so we invite everyone to participate, even if you haven't submitted anything for round 1. In summary, by curating the CORD-19 dataset and organizing these shared tasks and competitions, what we're really hoping for is to create more connections between the computing and medical communities, such that we can better build systems to assist medical experts in the search for effective treatments or policy decisions. Whether our efforts are helpful or not, perhaps this moment will serve as a test for the potential for NLP and text finding applied to science. In closing, we'd like to thank our many collaborators on CORD-19, including the White House OSTP, Kaggle, the National Library of Medicine, Chan Zuckerberg Initiative, Microsoft Research, and Georgetown CSET. We'd also like to thank all the individual collaborators at AI2 and other organizations. And we'd like to really thank our collaborators at Kaggle, especially for hosting the CORD-19 Research Challenge, which has focused a lot of energy from the text finding community into tackling this current pandemic. And finally, we'd like to thank our collaborators who are putting together this Trek shared task with us. I've included links on this slide to download CORD-19, also access to our discussion forum. We just uploaded our preprint to archive, which we encourage everyone to take a look at. It contains more details about the data set, a detailed survey about what people are working on, and some of our thoughts looking forward. The QR code is provided on the screen. And yeah, feel free to reach out to us via email or Twitter. And if you're interested in the Trek Share Task, please join the Google group. The name's on the screen. Thanks.
Thanks, Kyle. Thanks, Lucy, before that. Kyle, why don't you leave that slide up on the screen for a few minutes? And do you two, Kyle and Lucy, want to respond to a few more questions before we go to our next?
Yeah. That sounds great, Seth. There's I think I've answered most of the questions in the chat, but there's a lot of questions in the Q&A, so maybe we can go through those quickly.
Sure thing.
So Al Mercado asks, how does it filter chemical structural data, such as drug candidates under development? I think maybe we need a little bit more context for this question, so if you could clarify, we can answer it shortly. We do not, so I mean, in relation to that question, we do release as a supplement to the CORD-19 dataset, the Chemical Association, I think, yeah, this CAS dataset, which has been provided to us under the CORD-19 license for redistribution, which is a data set of chemical compounds and their attributes, which could be useful in conjunction with CORD for discovering potential treatment molecules. Quality, I don't know, Kyle, do you know of any work out there that looks at, kind of tries to judge the quality of papers?
Quality of papers? Not to my knowledge. That seems like a tough problem.
Yeah, it's a tough problem. It's also a little bit dangerous, I want to say, just because I think there's like a lot of features of a paper that contribute to its quality. And I think if we train a machine learning model on kind of paper features to determine quality, it's very easy for that model to simply learn things like associating affiliation or authors with the goodness of a paper. And that's not, it's not really a very good thing for science, for the scientific community to do that. Obviously, there's ways to try to eliminate bias and do other things like that. We've seen some work that maybe looks at reviews of papers and trying to predict review scores. So that could be maybe relevant. We can share those links. Do the sources other than WHO indicate which papers are related, or do we make that decision? We use a particular search string of just like different coronavirus associated keywords for identifying papers that fit into CORD-19. And that search string is available on the CORD-19 website for those who are interested. It's a set of maybe 6 or 7 keywords. Table parses. Yes. So I think when we refer to table parses, we are talking about a structured representation of a table, maybe like an HTML table that allows you to see, what values are in each of the rows and columns. And sometimes the answers for certain medical questions, like maybe you care about like odds ratio or whether a treatment shows significant improvement over like a placebo, those numbers are mostly represented in the tables. And it would be great to have a structured representation of the tables from which people can extract results. Kyle, you wanna?
Oh yeah, sure. What is this? There's a question. I was playing with the answer live button. That was pretty cool.
Oh yeah.
Well, this is great that you're playing weekly to daily updates, announcements on changes in format. Ah, yes. We do have a change log that goes out with each release that sort of details any sort of major changes, such as papers that are added or deleted and maybe changes to the schema. Unfortunately, we're hoping that people know that this is a evolving corpus, because like if we identify something that's really useful, which necessitates a change in schema, we will go forward with doing this. So yeah, that's sort of expect changes that might break things.
Yeah, but we will try to document those.
Yes, we'll try to document those
as possible.
And we won't just be making crazy random changes for the fun of it. Yeah. Is your JSON format related to Buos? I don't know what that is. Lucy, have you heard of that?
We don't know what that is.
Sorry, we don't know. Any chance to try Amazon's text track for PDF processing? I haven't. Lucy, have you tried?
I have not either. There's been a number of different organizations that have reached out to us to kind of try to help us improve the PDF to JSON part of the pipeline. So we are working with a number of different collaborators to try to improve the qualities.
Yeah. Let's see. How is there a tool you're using? Oh, okay. We're currently using Grobid, which is an open source tool for parsing the PDF into some sort of structured XML-like format. And then we have an in-house parser that's on top of that parses the XML into this JSON format that we currently release, which also does some fixing of like mistakes that occur in Grobid. Does JSON indicate whether the report has been peer-reviewed or not? No, we currently don't do that. Lucy,
so no, but any paper that comes, or any preprint that comes from bioRxiv or medRxiv would be not peer-reviewed.
Right. Yeah.
If you guys don't mind, let's take a pause and go to our second speaker. Let's stay
Sounds
on
great.
the line, and we'll come back to you.
Great. Yeah.
So we added a second speaker who is Róbert Péter from the University of Szeged in Hungary. The Hungarian NLP meetup is one of our co-sponsors, co-hosts today. So we're really glad to have him give a short talk on the use of a text mining tool called AVOBMAT, which is analysis and visualization of bibliographic metadata in text. So Róbert, why don't you take it away? And you'll speak for a few minutes, take a few questions for you, and then we'll open it up for more discussion after that.
All right, thank you for your kind introduction. All right, first let me just introduce the AVOBMAT team. Gábor Berend supervises the implementation of the NLP techniques in AVOBMAT, and Zsolt Szántó and József Seres have been responsible for the software development. This is a simple tool, a text mining tool in which we integrated the COVID-19 corpus. In this very brief talk, I'd like to summarize the objective of AVOBMAT and illustrate the different functions of AVOBMAT with specific examples. First, let's have a look at what is the most important goal of AVOBMAT: analysis and visualization of bibliographic metadata and text. The idea was to provide a critical and interactive analysis of bibliographic metadata and text with data-driven and NLP methods supported by AI techniques in a number of languages. We thought that medical researchers, medical professionals might profit from AVOBMAT because the service is user-friendly and they can easily text mine the corpus and discover new insights. Some background information about the project. Primarily, the AVOBMAT was designed for digital humanities research. We only published a simplified beta version of AVOBMAT, and several functions are not accessible, such as the pre-processing and the upload functions. And it is hosted on our university library service with basic parameters. And as for the technical background, we use Elasticsearch and Spacy. So how can we search the COVID-19 database? There are 4 options: the facet search, the date range search, the advanced search, and the command line search. Yeah, there's a screenshot here, and this is the well-known faceted search. Proximity search might be useful because users can basically find words within a specific word distance, and they can even, AVOBMAT can even consider the order of these search terms. There is a command line search with the help of which they can formulate complex queries by using the Lucian syntax. They can use regular expressions, and we abbreviated the names of the meta fields, as you can see on the right. There is a keyword in context function. If users do not want to read the entire articles, they can basically read only the context of their keywords. They can set the length of these contexts and the number of documents to be displayed. This is just an example for the keyword in context function. You can also rearrange the publication years and the authors. There are 3 complex frequent analysis and word clouds. There are significant text spheres, and word cloud. The significant text analysis highlights the words that are most strongly related to the selected subset or subcorpus of the documents that the users filtered by different searches, and it compares them to the entire COVID database. In other words, it identifies the unique words characteristics of that subcorpus. You've got some parameters that you can set, metrics such as the chi-square matrix, the number of words to appear in this word cloud, and the sample size of the documents. In this example, you can see that I search for the term chloroquine, and the word cloud shows those most strongly related words to the almost 500 articles mentioning the word chloroquine compared to the entire data set. You can have a look at the results in a bar chart view, the list of the words, characteristic words of this corpus. There is a text sphere visualization, the position and context aware text cloud, where you can create text clouds showing the occurring words of a specified search term in a corresponding distance. This is just an example again for the word chloroquine. You can see those words which are in 3-word distance of the term. As you mentioned, the COVID-19 data set is a historical data set. I think the first article can be dated back to the early 1950s. So some users might find useful to have the distribution of certain keywords over time. So that's why we implemented the n-gram viewer. The n is here limited to 3. And in this example, you can see the PCR and LEM, the distribution of the search term PCR, LEM, which are used to detect the coronavirus. And this is the normalized view. There are some interactive metadata visualizations as well. One of them is a network visualization. Again, I searched the term chloroquine in the abstract, and in this network, you can see the top 5 authors who published the greatest number of articles about chloroquine and the related journals, as well as the publication years. This is a similar pie chart visualization. And lastly, I'd like to show you the topic modeling function. We pre-processed the COVID-19 database. We lemmatized the text. There was a language detection, and there was a stop filtering as well. In this example, I searched for the term malaria in the abstracts, and we have about 300 articles altogether. And now I'd like to switch a screen and to show you the, can you see the screen now with the AVOBMAT surface?
Yes, it's good.
All right, so you can see on the left the different topic clusters. I set the number of topics to 15. And as you can see, for example, the third topic is related to the detection methods of malaria. All the articles in this cluster are related to that. Or topic number 7 is related to the treatment of malaria, as the title also confirms this. There is a topic correlation visualization in the software, and you can also look at the clusters of different topics of time series, aggregated and normalized view as well, and you can switch on and off the different topics. There is also a function with the help of which you can remove unnecessary words from the corpus, and you can download the results of the topic modeling in several different formats. Thank you for your attention.
All right, I'm not sure whether we have any questions that were specifically addressed to Robert. I will just give a very quick opportunity for any of your colleagues who wish to say anything, to add anything to what you've already said, to unmute themselves, turn on their video, and add a few words if you wish to. Otherwise, Kyle and Lucy, I don't know whether you've been monitoring the chat and the Q&A for additional questions that you would like to answer live. So let's give a second to see whether any of the folks from Hungary want to add anything to what your colleague has just said. Not hearing anything, let's open up the floor again. We're all figuring out how to do these kind of things online. This is the first meetup I've had 2 different speakers on a related topic, so I hadn't really anticipated the kind of maybe a melange of questions and not knowing who they're going to be addressed to. But if Lucy and Kyle, I'll invite you to unmute yourselves and to add anything further in response to the questions that have been entered, or for that matter, in response to Robert's talk. In particular, I would be curious if you, from where you sit at LNAI, whether you've seen similar text mining initiatives. There are a whole lot of things being done with this data set. What kind of things have you seen that you might add to the conversation today?
Sorry, actually, I got distracted a little bit. It looks like there is a question in the Q&A for Robert, if you want to.
One of the questions was concerned whether this tool is public. Yes, you can see the link here, and you can get access to the AVOBMAT tool with the integration of the COVID-19 dataset.
Thank you, Robert. I'm wondering, you know, for us, as you've been using the CORD-19 dataset, are there any kind of things that in the dataset that you would like, or which you think would make it easier for the community to work with the dataset?
We've got some comments from a virologist and a biologist at the University of Szeged who use the AVOBMAT corpus or text mining tool, and there were some issues. They couldn't find several articles related to their research projects, which were, for example, openly available, for example, in PubMed, or several of the databases that you showed to us. And they published, I think one of them was published, came out early January. And I basically just said to them that we cannot influence the content of the COVID-19 data sets. So I don't know how comprehensive it is, or what principle you need to consider when you add a new article or a set of articles, copyright reasons, or.
Yeah, so that's really interesting. Currently, we only pull articles from PubMed Central due to copyright issues. So if the paper is, for example, indexed in PubMed, but not in PubMed Central, it would currently not be included in the data set, but we would love to kind of increase the coverage of these sources if we are allowed to. But I mean, we alluded to this a little bit before, but there's certainly kind of legal constraints to what we can do and what we can re-release and republish as part of the data set. And it would be great if we, if there was just like more access to this content for researchers.
All right, thank you.
Yeah. I don't know if there's any other questions. There is a question in Q&A for you, Robert, about how you're calculating the n-grams. Not sure if you want to address that.
Yes, basically we added up the n-grams of a specific term and divided by the all the terms appearing in the very same year. So when that's how we calculated the normalized view in the n-gram.
There's also a question in here: is AVOBMAT open source to allow analysis for other large data sets, databases?
Yes, later it will be available. Definitely, it is the beta version only, but we wanted to release AVOBMAT only in December 2020, but because of the new coronavirus crisis, we decided to publish the beta version. Yes, just revisit the link, and it will be basically available to the public.
Okay, audience members, any further questions, please enter them now, preferably in the Q&A rather than in the chat. I'll give you another few seconds to do that, and if we don't see any, then we will wrap up. I do see a question here from Yefim. How do you handle the papers that were published but later retracted?
It's a very good question. I believe that currently we include them in the data set. But as a paper is retracted, the title of the paper is often replaced with retracted, the title of the paper. I think it's important to include these in the data set as kind of like a historical representation of what was disseminated about the subject of COVID-19. But it is also really important that we mark them as retracted as soon as we know that they are.
I wonder if that's sufficient, because what if you do have someone who's doing text mining on these papers and yeah, they don't pick up the fact that retracted is in the title?
Yeah, I don't know if Kyle wants to address. We certainly work with annotators, and
yeah, I think that's one of those things where it's like an interesting question about where the separation of work is between dataset curators, like corpus curators, and downstream applications. Like, we can certainly, if we removed those papers for people, that would definitely make it easier from a text mining perspective, but we would lose out on opportunities for people who want to actually use those retracted articles for any sort of learnings. But by keeping them around, then we put a little bit extra burden onto people building applications to make sure that they handle their own data cleaning and filtering to catch these type of cases. So we're still trying to like figure out where like a good balance of like how much effort do we put in to do this thing for everyone while not trying to bias it towards one particular type of application versus another. Does that help?
Yeah.
All right, everyone, I think we'll wrap for today. It's just going on an hour from the program start. So thank you, Kyle Lowe and Lucy Lu Wang from LNAI, and Róbert Péter and your colleagues from Hungary for participating today. We do have another meetup that is scheduled. It's not listed on all of the meetups that have been participating, but on May the 26th, that meetup is Question Answering Beyond Squad, Larger Datasets and New Domains, with Brandon Chan, who's an NLP engineer at DeepSet.ai in Berlin. I also have a speaker for May the 11th, so that is in 2 weeks, but he has not yet provided the information necessary to post his talk, so it's not posted yet, but we are aiming to do these NLP meetups every 2 weeks. If you would like to give a presentation, it could be anything from really short 5 minutes, including student work, to up to 50 minutes, then you can send me a note via the NLP, the New York or DC NLP meetups, and I'm actually going to type my email address into the chat so that you can send me a note if you have an interest in giving a NLP meetup talk. And I hope that you found this useful, and thank you for attending today.
Thank you, everyone.
Thank you.
Thanks, everyone.
Thank you. Bye-bye.
Thank you. Bye.